Good morning, dear students. Today we are going to continue the second part of the binomial theorem. Today's lecture we will deal with independent term, then total number of terms when you expand binomial expansion, and then we have properties of binomial coefficients and binomial theorem for any index. Fine. So we will start with first independent term. So in binomial expansion, you have to find the independent term and its value. Now I'll take a first example to get this. The term independent of x in 3 by 2 x square minus 1 by 3x whole to the power n is. These are options. Fine. Now the question is the term independent. The meaning of independent term, independent of x, or sometimes it is written as constant term, or it is free from x. So let's say we'll take one very simple example, x plus 1 by x whole square. If you expand this, you will have x square plus 2 into x into 1 by x plus 1 by x square. So what left? X square plus 2 plus 1 by x square. Correct? So this 2, here there is no x. So in this expansion, x plus 1 by x whole square, 2 is known as independent term of x. Or we can say constant term of x. So there is no x or free from x. So here it is simple because it's a whole square. So we have expanded and we came to know that 2 is an independent term and first and second term and its value is 2. But when the power is whole 9, when the power is bigger, then we cannot expand. Fine, means it takes time. So for this what we will do, we will get the TR general term of this expansion from where the term is generated, and then we will equate the power of x equals to 0, because then only the power of x equals to 0, then only it becomes an independent term. So first for this expansion, we'll get the TR plus 1th term. TR plus 1th term of this expansion. So 9CR, NCR, x you know 3 by 2 x square, 9 minus r into y. Y is 1 minus 3x to the power r. So this way we have written TR plus 1th term of this expansion. Now we will accumulate the powers of x in one place. So we have 9CR 3 by 2 to the power n minus r, x 2 power to the power multiply 18 minus 2r, and this x to the power r will go here and it becomes minus r into minus 1 by 3 to the power r left. Correct? So now this power, the power of x for independent term, what we will do? We will equate to 0. So then only the constant term you will get. So what we did, we collected the power of x in one place, and then this power we have to equate to 0. Fine, to get a constant term or independent term. So from here r we have 6. Correct? Now, so 7th term in this expansion, there will be no x and its value, because the term independent, we are not going to tell the term their value. What would be the value of that independent term? So the 7th term is your independent term, and its value is, so wherever r we'll put 6. 9c6 here, 3 by 2 to the power 9 minus 6, 3. This is going to be 0, and here it is minus 1 by 3 to the power 6. Correct? When you simplify this, NC6 3 by 2 whole cube minus 1 by 3 whole 6, it is going to be, after simplification, it will be 7 by 80. So this is the answer. Correct? So I believe all of you understood this. In constant term or independent term, we first find the TR plus general term, then we accumulate the power of x in one place. We collected the power of x in one place, and this power should be 0. Then only there is no x. So while equating this 0, we have r equals to 6, and then we came to know the 7th term will contain the constant term. And what is that value? So wherever r, we substitute the value of 6, 9c6, 3 by 2, 9 minus 6, and minus 1 by 3 whole to the power 6. So value came after simplification 7 by 80. Correct? Now we'll go to the one more problem in term independent of x. Look at this. The term independent of x in the expansion of x square minus 1 by 3x whole to the power 9 is, options we have correct. Now same process, again we have to find the term independent of x, and that in fact the value of that. So in the same sum, what we'll do, we'll get the tr plus 1 term. So for this expansion, we'll find first tr plus 1. So what is going to be 9cr x, which is x squared, n minus r, y is minus 1 by 3x to the power r. Correct? Now, again we will accumulate the power of x in one place. So 9cr x to the power, it is going to be 18 minus 2r, and from here x to the power, it came here, it becomes minus r, left with minus 1 by 3 to the power r. Fine. Now this power has to be for independent term, for constant term. For independent term, what should be there? 8 minus 3r should be equal to 0. Fine. So r also came here in this situation 6. So 7th term will contain no x of this binomial expansion. Fine. Then what is the value of that? So that's t7 is going to be an independent term or constant term, and its value is 9c6 since r is 6, and here it is minus 1 by 3 to the power 6, because if you put 6 here, it becomes x to the power 0, and that is what it becomes a constant term. So 9c6 minus 1 by 3 whole to the power 6, and this is even power, so positive, and this is going to, after simplification, the answer 28 by 243, that you can calculate with NCR and then simplify. Fine. So this way the independent term we can calculate. Fine. So I believe all of you understood this also. tr plus 1 you open, then collect the power of x in one place. 18 minus 3r came, equate to 0 for constant term. R we have 6. The 7th term becomes an independent term, and then you put r equals to 6 in this expression. So 9c6 and minus 1 by 3 whole to power 6. When you simplify this, 28 upon 243 it will come. Fine. So in independent term, I believe you can do it whenever independent term, constant term, or free from x. If these three terminology is used in independent term, constant term, or free from x. Now, see in the independent term, sometimes what happens, the independent term value is given, then you have to find the missing something. Let's say we have question, if the 4th term in expansion of 2 by 3x minus 3 by 2x square is independent of x, then n is equal to, this is going to be n is equal to 5, 6, 9, none. Fine. Here in this question, what it is given, the 4th term is independent of this binomial. Then we have to find the n. The expansion's power we have to find. Fourth term is independent is given, and then we have to find this n. So in this again we will write the general term. So fourth term, that means 3 plus 1 of this expansion. So r is 3, this is r. So nc3 x to the power n minus 3 into r, which is minus 3 by 2x to the power r. Correct? This way we have written general term. Now we will collect the powers of x, and that powers of x does not contain this one 0. It should be, the power should be 0. So here nc3 2 by 3, and fourth term in the expansion of the independent term, that is given. Fourth term is independent term, it is fine. So power should be then 2 by 3 n minus 3, and here it is minus 3 by 2. It should be r, and x to the power n minus 3, n minus 3. So independent of term, that means the value should be, the power of x should be minus 3, and this way it appears. Clear? Now this n minus 6, this should be what? 0. Then only independent term it will come. So n minus 6 equals to 0, therefore n is 6. 6 is the correct answer. Fine? Very simple. What we have done? We collected the power of x in one place, x to the power n minus 3, and here it is x to the power, rather than r, what I did, I put 3. See, r is 3 here. So n minus 6. So for independent term, what happens? The power should be equal to 0. So n minus 6 equals to 0, therefore n equals to 6. So 6 is the answer. Sometime in this independent term, the value of independent term is given. Suppose here some value is given, independent term. Then we have to find the some missing one. So such type of problem also, it can be in independent term. Find here. So these are few sums based on independent term. Now we'll move to second segment, where we'll discuss total number of terms after simplification. Fine. There is one method we came to know, total number of terms in multinomial expansion. Fine. So there we have written n plus r minus 1, cr minus 1. Then let's say x plus y plus z plus w whole to the power 20. Total number of terms. So for this we have formula n plus r minus 1, cr minus 1, where n is this 20, r is 1, 2, 3, 4, minus 1, and 4 minus 1. So whatever the value it will come, that will tell you the total number of terms. This we already done in previous lecture. Now here there is a binomial terms, and after simplification what total number of terms we have to calculate. Look at this. For this we will write first one formula, so that if you remember that formula, it will be easy to calculate the total number of terms. See, in this we have x plus y to the power n plus x minus y to the power n. Second situation, x plus y to the power n minus x minus y to the power n. Fine. Now here, if n is odd, the power of n is odd. If n is odd, then total number of terms is n plus 1 by 2 terms. Correct? If suppose we have, let's say, x plus a to the power n plus x minus a, let's say it is 5. So after simplification, how many terms you will get? So this is 5 plus 1 by 2, which is 3 terms. Clear? So after, when you simplify this, you will get 3 terms only. Understood? No need to expand. With the help of this result, you can get the total number of terms. Here also, if it is minus here and n is odd, if n is odd, the power is odd, again the same n plus 1 by 2th term. Suppose in this sum, if it is minus here, again after simplification we will get 3 terms. Fine? So n is odd, we will have n plus 1 by 2 term. Now in the same situation, if n is even, in this, n is even, then total number of terms is n by 2 plus 1 terms. Fine? So let's say if I take power here 8 and plus here, so the total number of terms will be 8 by 2 plus 1, which is 5 terms. Fine? When you expand this, after simplification we will get 5 terms with the help of this formula, because n is even there, it is mentioned. And for this, if n is even, in this situation when it is minus, n is even, then total number of terms is n by 2 terms. So let's say if we have x plus 5 whole 10 minus x minus 5 whole 10, so we will get 10 by 2 terms here. That means 5 terms. Fine. So these 4 results, if you remember, see, for this, when n is odd in plus or minus, there is one result, which is n plus 1 by 2 terms. But when it is power even, plus, we have n by 2 plus 1. When it is minus here, n by 2 terms. Fine. So this result, if you remember, so that what will happen, there are some, it came in by NDA, where we have to find after simplification total number of terms. So with the help of these 4 results, in fact here for n odd plus n minus, the result is same, n plus 1 by 2. For even we have plus n by 2 plus 1, if it is minus n by 2 terms. Fine. Now we'll see a couple of questions based on this. This is known as after simplification, total number of terms. So no need to open the binomial. With the help of this result, we can get the total number of terms. Now see, we have a couple of questions. Question is, total number of terms in this expansion plus is 9, 10, 5, 50. We have to tell the total number of terms in this expansion. See here, power is odd, fine, and it is plus. So we know the formula, n plus 1 by 2 terms. Fine. So what will happen? 9 plus 1, 10 by 2, which is 5 terms. So 5 is the answer. Clear? What we did here, it is n and 9, n is 9, which is odd. So for odd, we know that when it is plus or minus both situation, we have formula n plus 1 by 2 terms. So we have 5 terms. When you expand this, we will get the 5 terms. We are not here to tell the values of those terms. Here we are telling the total number of terms after simplification. So with the help of that formula, n plus 1 by 2, we'll have 5 terms. Fine. See the another one situation. Total number of terms in the expansion of 100 plus x minus a 100 is 202, 51, 50, none. For this expansion also, we have to tell the total number of terms. So see here, it is even, and plus it is given. So when it is even and when we have a plus in between, so then the formula is n plus n by 2 total number of terms. So that result, if you remember, it becomes very easy, n by 2 plus 1 terms. which is 100 by 2, 50 plus 1, which becomes 51 terms. Fine. So it is even power, and here in between plus. So the result, what we said, n by 2 plus 1. In result we came to know when power even and in between it is plus. So result says n by 2 plus 1. N is power, that 100. So 51 is the answer. When you expand, when you without expanding, we can tell the total number of terms. Fine, dear. So in this article, what we came to know, that if you remember those four results, what we have written, x plus a whole to the power n plus x minus a whole to the power n, and those four results, these type of sums you can do it. एनडीए में इस तरह के प्रॉब्लम आते हैं तो आप वो रिजल्ट याद रखिए, इट विल हेल्प यू. फाइन. नाउ डियर, now we will move to the area which is binomial theorem for any index, for any power. We did in first lecture binomial theorem for positive integral index. Now we will deal with binomial theorem for any index, any power. Let's say x plus y to the power minus 3, x plus y to the power minus 5 by 4, and so on. Correct? So we'll start with binomial theorem for any index.